Good afternoon. These notes are going to be on function tables and graphs. The first thing that we need to do is we're going to translate our sentence into an algebraic equation. So for example, this first says y is equal to 1 less than 2 times x, and we're actually going to write that out algebraically with symbols, letters, and operations. Number 2, fill in the table with the equation and substitute the values given, and I'll show you how to do that in the table. Then step 3, use your new y values and create ordered pairs to then graph on this side. So the first thing we've got to do is we've got to translate this into an algebraic equation. Y is equal to 1 less than, so I'm going to subtract 1, 2 times x, 2x. So here's my equation, y equals 2x minus 1. Then we're going to take this equation, y equals 2x minus 1, and we're going to put the 2x minus 1 piece right here, and that's going to equal to our y value. So we're going to take the 2, we're going to substitute it in for x, because these are all of our x values, and then we're going to get our y value. So 2 times 2 minus 1. Then this one is going to say 2 times 4 minus 1. And then we're going to write this again. 2 times, well this times 6 minus 1. And then again write this, 2 times 8 minus 1. So notice how every time what I did was I took the equation, I inputted the value of x where the variable was in the equation, and now we're going to just simplify. 2 times 2 is 4, 4 minus 1 is 3. 2 times 4 is 8, 8 minus 1 is 7. 2 times 6 is 12, 12 minus 1 is 11. 2 times 8 is 16, 16 minus 1 is 15. So now we have some y values. We also have these x values, so we're going to make our ordered pairs. So our ordered pairs are 2, 3. Our next ordered pair is 4, 7. Our next ordered pair is 6, 11. And our next ordered pair is 8, 15. So what we've just done is we have taken an equation, we took some values given, we inputted those into the equation, and then simplified them to give our y values, and then we made our ordered pairs. Now we're going to go over to our graph and we're going to graph these. What we need to do is look at our x values and see how high they go, and that will decide how we're going to label our graph on our x-axis. Then we're going to look at our y values and see how high they go. That's how we're going to determine how we're going to label our y-axis. This only goes up to 8, so we could probably just number them 1 through 8 and just count by ones. If we do that, that'll land us right here. So that gives us up to 8. So I'm just going to label every other 1, 2, 4, 6, 8. And that's as far as we need to go. We need to go up to 15, so let's count how many we have. We only have 11 spaces, so we can't count by 1. So let's count by 2s. So this is 2, 4, 6, 8, 10, 12, 14, 16. And that's as far as we need to go because our highest y value is 15. So now we just get to graph these. So 2, 3, so go over 2 and go up to 3. And 3 is going to be right here in the middle because we counted by 2s. So we're right in between 2 and 4. 4, 7, so go over 4 and then go up to 7, and again 7 is going to be between the 6 and 8 because we had to count these by 2s. 6 and 11, so go over 6, go up to 11, and 11 is going to be right in between the 10 and 12. And then 8, 15, so go over 8 and go up to 15. 15 is going to be right in between 14 and 16. All right, and then what you do is you just get to kind of connect these points and make a nice linear function. I'll just darken these circles a little bit. And then we are done. So we took a word equation, we translated it into an algebraic equation, we then took that, put it into a table. From our table, we got our ordered pairs. From our ordered pairs, we then graphed on a coordinate plane. So pretty much we're bringing everything all together. So translating, substituting, ordered pairs, graphing. Our next one says y is equal to the product of 3 and x. So 3x. This one looks pretty simple because it's just a one-step equation where this one was 2 steps. This is just a nice one-step equation. So let's put our 3x, and then our equal sign, because there's our equation, just the y is on the other side. And now we're just going to simply input our 0 into our variable here. So 3 times 0, which is 0. Then we're going to input 1 into our variable. So 3 times 1. Put 3 into our variable. 3 times 3. 5 into our variable. 3 times 5. And then just simplify over here. So 3, 9, 15.
Mr. Collins, please report to trailer 5. Again, Mr. Collins, please report to mobile unit number 5. Thank you.
All right, so we are right here, and we are looking at our ordered pairs. I just made them while they were doing the announcement. Our x value and our y value makes an order pair 0, 0. Our x value 1 and our y value 3 make an order pair 1, 3. This is 3, 9, and this was 5, 15. Now we're going to go over here, and we're going to kind of, we're going to graph. This is only going from 0 to 5, and we have a lot of space. So maybe we can skip every other one and label. So this can be 1, 2, 3, 4, 5, and that takes care of all of our x values. Now let's look at our y values. We're going all the way up to 15, so we're going to have to do the same thing we did here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. If you want to go ahead and label the ones in between, you can. You do what you need to do. So I'm going to go ahead and start labeling them. All right, and then we're going to graph. 0, 0 is right here at the origin. 1, 3 over 1 up 3. 3, 9 over 3 and up to 9, which is going to be between the 10 and 8. And 5, 15 over 5 and up 15, which is between 14 and 16. There we are. And then I'm going to connect my line because that's a nice linear function. Make my dots just a little bigger. And there's my linear function. Again, we took the word equation, we translated it into an algebraic expression. We took the algebraic equation, we took the algebraic rule, put it into our function table, took each value of x, put it in for the variable x, and then we got our y value, changed those to ordered pairs, and then graphed them. All right, let's try another one. Y equals 2 times x plus 2. Y equals 2 times x plus 2. All right, so we've just translated. Now we're going to write our rule into the function table. And then we're just going to replace x with each of these values of x. So 2 times 0 plus 2, 2 times 4 plus 2, 2 times 5 plus 2, 2 times 6 plus 2. Notice how I used parentheses for this one and I used a dot for this one. Both are fine. So it's whatever your preference is. All right, following order of operations, I'm going to multiply. That's 0 plus 2 is 2. That's 8 plus 2 is 10. That's 10 plus 2 is 12. And that's 12 plus 2 is 14. All right, now I'm going to make my ordered pairs. 0, 2, 4, 10, 5, 12, and 6, 14. On my coordinate plane, I'm going to label. I'm going up to 6, and it looks like I'm going to have enough space. I'm going to go ahead and just kind of spread out the wealth and make that 1, 2, 3, 4, 5, 6. And then going up, I'm going to count by 2s again. So 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. And then if you can label every other one, or all the other ones, you can, just to help out. Okay. 0, 2, so over 0 up 2. 4, 10 over 4 and up to 10. 5, 12 over 5 up to 12. And 6, 14 over 6 and up to 14. And then you can connect your points. It should make a nice straight line. It's called a linear function, and then you're done. So that's how you do function tables and graphs. What we're going to now do is go to the inside where there's a little bit more to it. So now what we're going to do is we actually have to determine the equation that matches the table. So for example, To determine what function equation rule is, you have to ask yourself this. What am I doing to x to get to y? Are you adding or subtracting? Are you multiplying or dividing? Or are you doing a combination of more than just one thing? So when I looked at this equation here, I said, oh, I'm going to take my x and divide by 2. Take my x, divide by 2. Take my x, divide by 2. Take my x, divide by 2. It has to work every time. So my equation is y equals x divided by 2. And then that's it. That's all you have to do. For this next one, I'm going to tell you this is a combination because I tried to do plus. So I said, ooh, plus 3, nope, it doesn't work. Times 2.5, times 2.5, times 2.5, oh, times 2.5, nope, that doesn't work. Because 4 times 8 times 2, 8 times 2.5 is 20. So it does not work to times 2.5. And then 6 times 2.5, I don't think is 13. I think it's 14 or 15, yeah. So it's not times 2.5 either. So then I decided, okay, let me see if it's a combination of some things. So here's a really cool trick you can do. To get what you're multiplying or dividing by, we're going to see what we're adding here. So this is plus 4, this is plus 2. And what you do is you put your change in y over your change in x. So 4 divided by 2 gives me 2. So that's my multiplier. So it's 2 times x. So 2 times x is 4, but that doesn't get me 5. So what can I do? What's another step I can do to make this 5? I can add 1. So let's see if that works. What's 2 times 4? 8 plus 1, 9. What's 6 times 2? 12 plus 1, 13. What's 8 times 2? 16 plus 1, 17. So the 2x plus 1 works. So if I double these and add 1, I get these. And again, the shortcut was this. We found the difference here, we divided y by x. So 4 divided by 2, and we got 2, and that's what gave us our number that multiplies x. Okay, you'll learn later in 7+ and in 8th grade that this is called your slope or your rate of change. But right now, for our case for 6th grade, we're just going to call that like our multiplier. Okay? All right, so let's go here. Let's see if we can start off simple. So I always ask myself, am I adding, subtracting, multiplying, or dividing anything? If I'm just doing the one thing, then I can move on. It's quick and easy. So for example here, plus 4, plus 4, plus 4, plus 4, plus 4, plus 4. It worked every time, so I know that my rule is y is equal to x plus 4. I didn't have to do a second step. It was just plus 4. Here, this one's a combination. So first I look, okay, plus 3, nope, that doesn't work. Times 3, no. Times 4, no. Maybe I can times by 3 and add 1. Times by 3 and add 1. No, that doesn't work. But another thing, so this one's actually pretty hard. So we're going to look at and see if we get the same thing. So this is 4 over 2. Oh, another thing is it has to be the same thing. So this is plus 2 and this is plus 4. So see how you get the same, it's 4 over 2. And then this is plus 2 and this one's plus 4. So you get 4 over 2 every time. Here it's not going to be the same because here it's plus 5 and that's plus 1. So you get 4 over 2, but then you get 5 over 1. So they're not the same. So this one's actually a hard one. What I saw with this one, and that's because it has the same second difference, and this is a challenge, is you're actually going to get this. It's an x squared plus 3. Do you guys remember how to square a number? So 0 squared is 0, plus 3 is 3. 2 squared is 4, plus 3 is 7. 3 squared is 9, plus 3 is 12. 4 squared is 16, plus 3 is 19. So all of those work. So I know that this one was a challenge, and that's okay. This one, if you just completely don't get it, we'll just keep practicing this so you can kind of recognize it. Okay? So let's go down here to some of these. This one's just hard. This one's hard to explain just because you guys aren't at the level for me to explain second differences in quadratic functions, and that's what this is, and we're just not at that level yet. So let's look at this one and see if there's anything that we can do that's the same. So add 8, okay. Add 8, nope. Add 8, nope. Times by 5, no. Times by 5, no. Okay. So then what we got to do is this. Let's see what the difference is. So plus 4 plus 2 plus 8 plus 4 plus 4 plus 2 plus 4 plus 2. So let's see if we get, so remember it's our y over x. 4 divided by 2, 2. 8 divided by 4, 2. 4 divided by 2, 2. 4 divided by 2 is 2. So we know that we keep getting a quotient of 2. So because we keep getting that quotient of 2 where it's your y divided by x, we know that that's going to be our number that we multiply by. So we know we're multiplying by 2, and then we got to do something else. So 2 times 2 is 4, and then 4 plus what gives you 10? 6. 4 times 2 is 8. 8 plus 6 is 14. That works. So we know that's going to be a plus 6. 8 times 2 is 16. 16 plus 6, 22. 2 times 10 is 20 plus 6 is 26. That works. 2 times 12 is 24 plus 6 is 30. So we know that that works. So again, how we got this number right here is we looked at the quotient of the change in the output over the change in the input. So your y over your x. All right, let's look here. So 1 to 1, 2 to 4, 5 to 25, 7 to 49, 8 to 64. This should be ringing a bell very, very quickly that all of these, I square the first to get the second. Square it, 5 squared, 7 squared, 8 squared. So this one should have kind of rung a tune, a familiar tune, that this should be x squared. All right, down here. So plus 11, okay, plus 11, okay, plus 11, that works, plus 11, that works. And, oh, okay, so all this is just x plus 11. So this one was one of those short, easy, just one-step equations. All right, over here, let's see, plus 6, note that doesn't work, times 3, note that doesn't work. So let's try our next trick. Let's see what the difference is. So that's plus 4 and 1. And that's plus 2 and, oh wait, this was 2, sorry. 5 to 6 is plus 1. 15, 9, that's 4, that's 2. This is plus 4, and that's plus 2. So let's see what they're different. Let's see what their quotients are. 4 divided by 2, 2. 2 divided by 1, 2. 4 divided by 2, 2. 4 divided by 2, 2. So our quotient every time of our output divided by our input was 2. So that's going to be our multiplier number. Again, it's called your slope, but we're not there in 6th grade. So we know we're multiplying times 2, and then we got to do something extra. So let's plug this in and see what we got to do. So 3 goes right here. So 2 times 3 is 6, plus how much more to get 9, plus 3. So let's see if this rule works. 5 times 2 is 10, plus 3 is 13, yep. 6 times 12, or 6 times 2 is 12, plus 3 is 15, yep. 8 times 2 is 16, 16 plus 3 is 19, yes. 10 times 2 is 20, 20 plus 3 is 23, yes. So 2x plus 3 works. Okay? All right, so now what I want you to do is I want you to go ahead and try these next 3 on your own. And then pause the video whenever you are ready, and I'll give you the answer keys. On the other side, on the third side, same thing. Try to find the rules, plug them in, see what you got. Go ahead and pause the video, and then you can look up to see what the answers are. All right, here are your answers for the bottom. This one was 2x plus 1 because I found a difference of 2 and 1, and 2 over 1, 2 over 1, 2 over 1, and then 6 over 3, which is still 2. And then I multiplied times 2 and then added 1 for my two-step equation. Here, this one was kind of straightforward and simple. I just had to divide by 3, so x over 3 or y equals x divided by 3. And so divide by 3, get 1, divide by 3, get 2, divide by 3, get 3. So that one was pretty straightforward. This one was 3x minus 2. Again, I saw the change in y to be 3 over 1, and it was the same every time. I kept getting 3, and then I subtracted 2 to get my second value. So 3x minus 2 is your answer there. Then on the right side, here are the answers. So here you got the numbers 5, 6, 8, and 10. Number 2, you got x plus 11. Number 3, I got 3x minus 2, which that one looks identical to this one. So I apologize for making that twice. This one, I got -5, 3, 5, and 7. And then we had to graph number 1 and number 4 from here and here. And so we graphed them right here, and here are the pictures of the graph. You did have to go into -5, so I kind of had to extend my coordinate plane. If you have any questions on this video, please go ahead and comment at the bottom. I know it was a super long one, and I apologize for that, but there was a lot of new information, and I just want to make sure that you were clear with all that. I will hopefully see you guys tomorrow, and have a great afternoon.